Welcome to our student. Now I am discussing regarding the NET question solution 2023 in the organic chemistry, and it is also helpful that of the JAM. In this video, I want to discuss the electrocyclic ring opening reaction. What is the electrocyclic ring opening reaction? In the electrocyclic ring opening, the disrotation or conrotation ring opening takes place. In this case, in case of the cyclopropyl tosyl systems, the 4n plus 2 pi means that is the 2 electron system. So it undergoes ring opening take place via the disrotation ring opening. And after the disrotation ring opening, it can either converted to that of the U shape or converted to that of the W shape ring opening structures. In here, if the OTS group and the methyl group present in the all are in the cis directions, then inward directions of the two methyl groups and the outer directions of the OTS group converted to that of the U shape structures. But in the opposite isomer, in case of the 7.26, we get that of the V-shape structures. And stereochemically, if we see that in that case, the W-shape structures is more sterically less hindered compared to that of the U-shape structure. So the rate of hydrolysis for that of the 7.26 structures is more compared to that of the 7.25 structures. And this happening observation is different in case of the cyclic system. Here, the chlorine group is in the endo phase with that of the cyclopentane ring systems, and here the endo molecules is ring formation is more favorable as it contains that of the U-shaped like structures, and the ring formation is favorable in the U-shaped structures. So after endo isomer, the ring cleavage occurs readily to give that of the chlorosubstituted allylic product. But in case of the exo isomer, the reaction did not take place. Here the region for that is the pericyclic reaction. Here the W-shaped geometry is attained in case of the cyclic system. So the W-shaped geometry is not maintained in that of the cyclic parameter. So it did not undergo the Cl group cleavage to give that of the desired allylic substituted product. In case of the endochlorosis substituted derivatives, here the bromine and the chlorine, bromine and chlorine, they may be departure from that system, but according to that of the pericyclic rules, the chlorine group is leave from that system from the endo isomer, but the bromine group is not leave from that system. But here, similarly, the endo-bromide group is leave from that system, but chlorine group is remain intact. So we get that of the two different isomer by varying the bromine and chlorine in their positions. Next, if we see that of the problem on the NET questions 2023, this observation was similar to that of the electrocyclic opening reaction. Here, the two bromine group can be leave from that system. Here, the R group and the R group is in the same side to that of the bromine, and the opposite orientation of the R group rotation with respect to the bromine group. That is the CBr bond is break in the one way, and the R to alkyl group is rotate in the opposite orientation, this rotation, and we get that is the U-shaped structures. And we know that the U-shaped structures is more favorable for that of the cyclic system, hence we get that of the allyl bromotriose substituted product. And so the option for this problem is the one option is the correct option. Now I am going to that of the epoxidation reaction. And the epoxidation reaction is very favorable in presence of the metachloroperbenzoic acids in presence of the DCN. But this is the sterically dependent epoxidation reaction. In the sterically dependent epoxidation reaction, it has been shown that the sterically less hindered substituted epoxidation phase is more favorable compared to the hindered phase. Here, the sterically less hindered phase means either epoxidation can occur in the top phase or in the bottom phase. Here, the bottom phase epoxidation is more favorable as the acyl group is present and the acetate group present in the top side. So the epoxidation takes place in the bottom side. But if we changes from that of the acetate group to that of the hydroxyl group, the epoxidation occurs in the opposite phase. Their intramolecular hydrogen bonding can facilitate the epoxidation reactions in the same phase to that of the hydroxyl groups, and we get that of the 92%, 92:8 ratio of the epoxidation product. And the desymmetrization can also occur if we see that of the compound 30 has no chiral center, but after the epoxidation the chirality can be arises. This is called desymmetrization. Here the epoxidation can occur to that of the less hindered phase, and we get that of the desired product. epoxide product. And this observation is taken from that of the Carothas groups. And this is the DMDO, dimethyl dioxidase. This can be prepared by treatment of the potassium permonosulfuric acids, and this potassium salt of permonosulfuric acid on treatment with that of the epoxide, it can form the dimethyl dioxidase, and this is the epoxiding agents, and this reagent is very important for the epoxidation reactions. And if we see that here the epoxidation can also take place in presence of the DMDO in the less hindered phase. Now, in the problem in the net questions, we see that in case of the tertiary butyl group and the methyl group present in the top sides, and if we see in the conformation in the envelope conformation, it has been shown that the epoxidation can take place to that of the less hindered phase after the treatment of that of the metachloroperbenzoic acid, and we get the epoxidation to that of the less hindered phase, that is the below phase epoxidation take place. But if we see that of the in presence of the NBS in water, the bromination take place to that of the less hindered side, but the water is coming from that of the top sides, and after that at SN2 type of the intramolecular reaction, we get the thin phase of the epoxide product. So the given problem for the answer is the true. Now, if we go to that of the oxidations of alkynes, in the oxidations of alkynes, we know that in presence of the KMnO4 or osmium tetroxide, alkene can convert it to that of the cis hydroxylations, but here ruthenium dioxide and sodium iodate is used for that of the oxidations of alkynes. The reaction is that the ruthenium dioxide is first oxidized by the sodium iodate to get that of the ruthenium tetroxide. It is just like that of the osmium tetroxides, and then the ruthenium tetroxide can undergo the oxidation in the following mechanism. Just like that of the osmium tetroxides, it can form that of the chelating rings, and after the chelating rings, it can break down to give that of the dicarbonyl compound, and we get that of the ruthenium dioxide. And further, ruthenium dioxide further oxidized by the sodium iodide, it get converted to the ruthenium tetroxide, and reactions occurs in the spontaneous way. So the catalytic amount of the ruthenium dioxide is needed for that condition. So the option for that reaction is that the 4 option is the correct, that is the dicarbonyl formation. Next, if we go to that of the photochemistry related problem, in this photochemistry related problem, it has been shown that here the pi bond and the carbonyl group present in that of the dipymethane rearrangement, oxo dipymethane rearrangement, and in the oxo dipymethane rearrangement, we know that the radical can be formed, that this is the diradical is formed, and then this diradical can add to that of the carbonyl, and after the cleavage of the CC bond, it produces the 3-degree radicals, and then the 3D radical undergoes dimerization with that of the remaining radicals to get that of the cyclopropane derivative with the cyclopentanone. And in another case, in case of the reaction go through the Norris type 1 cleavage, that is the alpha cleavage, it produces the carbonyl radicals, and then this carbonyl radical and the tertiary butyl radicals undergoes isomerization, and then intramolecular cyclization in 4-member ring is formed. So the given problem for that question is that the desired product can be obtained by the oxo dipymethane rearrangement and Norris type 1 cleavage. And the additional problem is given here, that is the dipymethane rearrangement. Here after the dipymethane rearrangement, the several type of the reaction can occur. Here the cyclopropane, this is the one type that the oxo dipymethane take place, and the dimerization after the decarbonylation, Norris type 1 dimerization can also take place. And this is the problem where the dipymethane rearrangement to give that of the cyclopropane derivative with that of the carbonyl derivative. Now, if we go to that of the next problem, that is the Diels-Alder reactions. Here in the Diels-Alder reactions, the cyclopentadiene can add to that of the vinyl sulfone derivatives, sulfoxide derivatives with the phenyl group. We get that of the bicyclic system, and if this bicyclic system can also be obtained by the reaction with the ethine with the cyclopentadiene. So the ethine is the precursor synthetic equivalent of the given problem. Now this JAM questions 2024 is coming in the next video, and the NET 2023 questions regarding the organic chemistry has been ended.